Hello everyone. In this video we'll be making glacial or anhydrous acetic acid from sodium acetate we made in another video. First, a word of warning. We'll be using concentrated sulfuric acid that can burn and blind you. Be sure to wear proper protection as sulfuric acid is unforgiving. To begin, you'll need 100 grams of anhydrous sodium acetate. You can make anhydrous sodium acetate by heating it very slowly on a hot plate or in an oven at 350. However, this can be very tricky as anhydrous sodium acetate can burn. Here is my first go at it. As you can see, I burned it pretty bad. After a couple of tries though, I was able to get it right. You will also need some 98% sulfuric acid. You don't have to have anhydrous or 98% sulfuric acid. You can also use air-dried sodium acetate and just plain old plumber's sulfuric acid if you like. However, your acetic acid will have some water in it. Place the sodium acetate in a 1 liter round bottom flask with some boiling stones. Now we're ready to add the acid. Now set your flask up in a heating mantle. Then add a 3-way adapter with an addition funnel containing about 150 milliliters of sulfuric acid on top of it. Now start slowly adding the acid dropwise. There may be a small amount of fizzing and the flask will heat up. Keep adding the acid until all the sodium acetate dissolves. You may have to pull the flask out and swirl it to get all the sodium acetate to dissolve off the sides of the flask. Please be careful doing this as the flask will be very hot. After most of the sodium acetate is dissolved, you can set up for simple distillation and turn on the heat. Capture what comes over at 118 degrees C and continue to distill until no more acetic acid is coming over. For me, this took about 45 minutes. When you're done, you should be left with glacial acetic acid. Be careful. Just like other acids, it fumes and if left open will fill the room with acid vapors that sting the eyes. Store in an airtight bottle. Now we're going to take a quick beginner's look at strong and weak acids. If your interests are only in synthesis, or you're a proficient chemist, you can drop off here. If you're new to chemistry, you may find the following helpful. Let's run a very simple experiment that everyone is familiar with. Here's baking soda and 5% acetic acid, known as vinegar. As you can see, they react vigorously, producing a lot of bubbles of CO2 gas. Now let's retry this experiment, but using anhydrous acetic acid instead of vinegar. Let's see what happens. We get a reaction, but nothing like the 5% solution. Why not? Well, you might say it's because there is no water for the baking soda to dissolve in. Well, let's add some water. Enough to dissolve the baking soda. And we get a reaction, but it's still not the reaction we get with the 5% solution. Why not? Well, it has to do with the fact that acetic acid is a weak acid. Many people think that the strength of an acid has to do with what it can dissolve. For example, a lot of people think that nitric acid is stronger than sulfuric acid because it can dissolve copper while sulfuric can't. However, this is not correct. Sulfuric is a stronger acid than nitric acid. In fact, mixing the two acids together to perform a nitration, the sulfuric acid donates a proton to the nitric acid. So in this reaction, nitric acid is actually performing the role of a base. The simplified definition of a strong and weak acid is this. Weak acids are only partially ionized in their solutions, whereas strong acids are completely ionized when dissolved in water. Since a weak acid is only partially ionized in a given amount of water, then counterintuitively, a concentrated amount of weak acid is not as reactive as a dilute solution. This is why the 5% solution of acetic acid is more reactive. The larger amount of water compared to the acid allows more acid to ionize, thus allowing more acid to react. So let's test this out. Here's some baking soda I'm dissolving in some water. Now here's a few drops of glacial acetic acid. As you can see, we got a strong reaction. Let's up it a bit to a milliliter of glacial acetic acid. Wow, a much more vigorous reaction, way more than the anhydrous alone. So once again, for a weak acid to strongly react, it must be in a dilute solution. It seems counterintuitive, but that's how it works. Thanks for watching.